All right, hey guys. So this is the What is Science notes. You should have your copy of the notes that you're getting ready to fill in. As you watch the PowerPoint, anything that's in red would be specifically stuff you want to get down. But keep in mind, you should always add stuff, make your notes personal to yourself. You hear the teacher say something that made sense to you or that you liked, jot it down on the side. You can always add more. There's no such thing as too many notes here. So the idea of this topic is we're trying to figure out what we're going to call the nature of science. What does science try to do? What can it do? What can it not do, etc. So let's just jump in with this first thing right here that says the fundamental belief of science. What would that be? Well, let's find out. How about this idea? Nature is governed by rules, all right? As people watch things happen around them, they notice, hey, this happens in the same way every time. This seems to have a pattern over here, you know. So basically, that's the whole idea. We live in a universe that's governed by rules. Let's see what we can do with that. So science usually doesn't use the word rules. It uses words like law or theory, etc., and so forth. So these are some examples of nature's rules that are pretty well known. Law of gravity, the atomic theory, theory of evolution. Um, just so you know, we'll study the first two a little bit. Evolution is more of a biology thing. So anyway, in your notes you're gonna, or in your, yeah, you should see some things that you're gonna want to underline or highlight, for example. So these bulleted items are very important for you to understand. So first of all, where it says does not change, oops, I don't draw a very straight line, do I? All right, that means over time, these rules don't change. You know, if you go back yesterday, gravity was the same as today. We could go back when the dinosaurs lived here, and the theory of evolution was working just the same. Also, the idea of everywhere. You know, we really haven't been everywhere in the universe. Humans are obviously, besides the Earth, we've been to the moon and we've orbited the Earth, but that's about it. We've sent probes, you know, to pretty much everywhere here in our solar system and some outside of it. But that's a small part of the universe. But our fundamental belief is that these rules are consistent everywhere throughout time, basically. No way to prove that, but it only makes sense that what we've got. The idea that these rules are understandable. Let me try my little pointer bar. So, look at that. That they're understandable is kind of important, all right? It's not like the world is so confusing, humans shouldn't even try to figure it out, all right? But here's a really big idea. Let's check this thing out. No. Whoops. Let me try that again. Boom. No. There we go. There's no rule book, no owner's manual, no answer key. You know how the teacher always has the answer key in the back of their book? The universe doesn't come with that, basically. So we're going to talk a little bit about how do we deal with that idea there, all right? So, all right. So in a nutshell, here's basically what's happening. You know, boom. Science tries to figure out nature's rule. You might circle or highlight that a little bit there with your markers there. Nature's got rules. Science's job is to figure out what they are, perhaps. Basically, when you read a science book or you listen to a science lecture or you go to a science museum or whatever, you're just learning the rules that people have learned in the past, basically. So, and trust me, there's a lot of rules left to learn here. So, how about an analogy, you say? We use analogies all the time in science. Got something that's new or hard to understand. It's too big, it's too small, it's too confusing. You try to say, well, it's like something else. It's kind of like a metaphor in your language arts class. So how about this? A sporting event that you're not familiar with. If you just happen to watch the Olympics, that's been pretty cool. There's been some cool stuff going on with that. There's some really interesting sports that I don't watch too often out there. So water polo might be one, for example. Could you figure out the rules of water polo? Obviously, there are rules. There's a rule book somewhere, but you just don't have it. If you just watch the game long enough, could you figure it out? All right. So, and then what if they allowed you, once you got some ideas in your head, I think this is a rule, there was a couple of teams that would allow you to call timeout and go down there and set up like a little Well, let's call it an experiment. All right. And let's see, this team's going to throw the ball and it's going to bounce off the goal and go out of bounds. Now what happens? Okay. And you could test to see if you really know the rules very well. So, really, what we're talking about here is if you just observe an experiment, basically do what scientists do with nature. Go out and look at it, come up with some ideas, figure out ways to try to test them and see if we're right, more or less. All right. So here's a good question. So science never really knows. There's no answer key. Remember, there's no owner's manual. So what good is it, you say? All right. People say, well, it's only a theory, or scientists are just guessing. Well, true and true, basically. But here it is, right here. Boom. Make accurate predictions. Let me give you some examples of what we're talking about. Make sure you get the word accurate in there. By the way, anybody can predict, but to predict accurately is what it's all about. So let's say you're going to build a bridge. How much can it support? Well, laws of forces in nature, etc., and mechanics will tell you, hey, it should support this much. Will an airplane fly the first time? Well, how fast do the jets go? How big are the wings? What shape are the wings? Here's one that's been kind of timely. How will a vaccine work on most people? All right, or will it work on most people? How about a spaceship landing on Mars? Doesn't that just blow your mind that we can launch a piece of metal on Earth and have it leave Earth, have it fly through space, millions and millions, hundreds of millions of miles, intercept an itty-bitty little rock out there in the middle of nowhere and successfully land on that? It's because the rules of science are predictable, and if we understand them well, we can get it right, basically, most of the time. So, the idea of taking these rules that we have and applying them, using them, basically, is engineering and technology. So, let's give a big cheer for Mr. Eckleberry right now in his class. Hopefully you guys are taking some of his modules. So, we got science, we got technology, we got engineering, STE. Which one are we missing here? Oh, we're missing the math one. So let's give Miss Miller some props here. Hey, so you live in a very mathematical place, and before you start frowning, let me tell you why that's an awesome thing. Because of this, we try to write all our rules as mathematical equations. That may sound crazy, but mathematical equations mean accurate predictions. Ding, ding, ding. Circle that. Get your highlighters out. Do a little woohoo. All right. So there's nothing more accurate than math. You're either right or you're wrong. So keep working on that. All right. Here's a quick example. You can just hit the pause button and write some of these down here. So one of the most famous equations ever, F equals ma. Force is mass times acceleration. If you know the force and you know the mass, well, then you should just do some simple algebra and calculate the acceleration. I'm thinking of like an amusement park ride. Those things work constantly all day long, and unless a piece of metal fails or an electric motor goes out, there's usually never any really problems with those. So yay. All right, moving on. So here's a good question. Can we just study anything we want? Sounds like science is awesome. It's powerful. It can do just about anything we want. And then you find out that the answer is a big fat no. All right. Let me tell you what science is limited to. You ready? 5 things. This will be on your homework and on your test and quiz too. So here they are. We're going to come back to what natural actually is, because it's going to mean a little bit different than what you think. All right. Observable kind of goes without saying, but a lot of great science discoveries happened when we found new ways to observe the universe. Telescopes and microscopes are the 2 biggest ideas there, basically, but other types of things that we could notice things before, and then our whole idea of the rules kind of change. We're going to say the word measurable in our class a lot. You're going to come up with your own ideas to do science here in the next couple weeks to practice. And the first question I'm going to say is, ooh, cool, what are you going to measure? Can you measure it? How accurately can you measure it? Because if you can't do those things, you can't call it science. Testable, so you got ideas, you got to be able to see if it's right or not. And if you can't only do it once, well, that doesn't count, basically. It's got to be repeatable. Not only that, but scientists repeat each other's experiments to try to get the same results, and then we feel really good about ideas there. So let's go back to this idea of nature here. Science has to study the natural world. Is there anything out there that's beyond nature, outside the rules of nature? Um, Ideas like things that are made out of plastic, for example, those we're going to call natural in our class. You use natural materials, you follow natural rules of chemistry, and you put the atoms together in different ways, and boom, you've got a piece of plastic, a new molecule, but it's still following the rules of nature. We're actually going to use the Latin word that means, beyond nature. And you've probably heard it before, but you probably think it means something else. And here's the word. Bum, 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 bum. Supernatural. Super really just means above or beyond. So this is outside of nature. So I say supernatural. What do you guys think of? Are you thinking? Really, what it truly means is it's outside of the rules. So obviously science can't study it. Maybe there are no rules. Maybe the rules change. Maybe somehow the rules can get made up in different ways, etc., and so forth there. So the rules that science study, remember, are the same everywhere all the time, and we focus on them and see if we can get them figured out, basically. So let's talk about supernatural here real fast. So some examples that are definitely supernatural would be the idea of a god or gods, however you might want to believe in that. Okay, so a lot of people believe in a god that's just can do anything, basically. God can create something out of nothing. The idea of miracles. If you think about what is a miracle to you, that shouldn't happen. Basically, miracles are where the rules got broken. And science believes the rules never do get broken. We may not understand the rules perfectly, but you can't break them. Maybe something supernatural can. Here's some maybe supernatural things. I don't know, these are fun to talk about, but they're out there on their own. I don't know if ghosts exist. Do they follow the rules? Or maybe they exist and they have their own set of rules. Magic? I don't know. I love Harry Potter. But if you think about Harry Potter, that's just a whole nother set of rules, isn't it? Harry Potter and wizards and witches can do magic that us muggles can't, basically. But they still have rules. I mean, that's why Harry's going to Hogwarts, is to learn this different set of rules, basically. If you know what ESP stands for, I'll give you a cookie. And there's no N there. So, hold on here. Let's do extra sensory perception. You can perceive something with an extra sense. You're supposed to have, 5 senses? So if you have an extra one, you have a sixth sense. So maybe there's something out there. These are all things that just aren't repeatable, basically. Let's put it that way. Weird things happen, but nobody can repeat it. Nobody can really measure it. It's hard to observe sometimes. So it's just sort of out there on the edge of science, and can't really call it real science yet. Real science has to be nailed down as best as possible. We're going to quickly talk about this idea of a worldview, then we're done here. So I don't know if anybody's mentioned that to you yet, but your worldview, it's not just how you view the world, it's how you see everything and understand and explain basically the universe, not just the natural stuff, but lots of other things too. So I'm going to give you a couple of options here. One of them is religion, and religion is based mostly on this word. Whoops, sorry, I need to use my laser pointer. Faith. So let me ask you a question. Do you do an experiment to test your faith? Do you have to be observable and measurable and testable? Most people would say not. My faith is my faith, right? So unlike science, which is on this word here, facts. So that's just the opposite. If you have an idea and you say it's scientific, do you have to be able to prove it? Yes. You have to be able to test it. You have to be able to measure and argue it, and it has to make sense and be logical, etc., and so forth there. So two very different ways of seeing the world. I'm just going to throw this at you here right now real fast. Some people will say you have to kind of pick one and go with it. You know, if you're a religious person, you got to kind of ignore some science, or if you're a science person, you've got no room for a religion. My own mind, I easily and very happily have both of them working in it. I think science and religion complement each other. They don't contradict each other. They go together in very good ways. Matter of fact, I would have a hard time explaining and understanding the world if I didn't use both. All right. So anyway, that's all I've got to say. If you got any questions, come in and see me. And thank you for listening. By the way, you're going to have some homework that you get to do with all this fun stuff. So, same thing. Ask me questions about that. Over and out.